Dear students, you have learnt about the local maximum and local minimum values in the previous sessions. In today's session, I am teaching you about the absolute maximum and absolute minimum values. Now, here I consider a function f of x is equal to x plus 3 defined in the interval, the open interval 0, 1. We observe that this is continuous function. The function is continuous in the interval 0, 1. But this function will not have a maximum value or a minimum value. Now, I will tell you why it is so. Let me take the interval 0 to 1, x is 0 and x is 1. So, this is how, this is the function here. Say x is equal to 0 and we will be taking a function like this, 0 to 1 it would be there, isn't it? So, here suppose the line is like this, then x takes the value 0 and it is actually a line, a straight line here. Let me consider like this. This is a continuous function. When you take the continuity, it would be continuous. In this interval, whichever point you take, the function will be continuous. We can see that one, we can verify that one. Now, let me take this as the x is equal to 0 and this is x is equal to 1. It is an open interval, these 2 points are not included. Suppose you take we cannot say exactly this is the least value or this is the greatest value. For example, let me take a point here x1. When you take a point x1 here, between 0 and x1, no, there exists infinite number of points. So, you cannot say this is the smallest. If I say this is the smallest, there is one less than that one. If that is the smallest, there is one less than that one. So, we cannot exactly say it is the smallest value. The same argument holds good here also. Suppose you take a point x2, I cannot say I am taking that point very near to 1 and very near to 0 here. So, this will not be exactly the greatest value. There may be one more than this. There may be one more than this. Therefore, I cannot say this is the smallest and this is the biggest. Suppose I change the interval to the closed interval 0, 1. If I take it as a closed interval, then automatically when you give the value 0, the value of the function is 3. When you take the value to be 1, it would be 4. So, for between 0 and 1, the values of function would be between 3 and 4. So, 3 becomes the least value, 4 becomes the greatest value. So, these values are known as absolute minimum value and this is the absolute maximum value. So, this is the how we define the absolute minimum value and maximum value, that is only when the function is defined on a closed interval. The next problem is how to find out the absolute value. Here this is the working rule. What I am telling is the working rule to find the absolute minimum and absolute maximum value. Now, let me consider a function, say, defined on the closed interval, say a comma b. A and b are the end points of the interval. Now, calculate f dash x. That is the first step. Step 1 is find f dash x and equate it to 0. So, what do you get here? When you equate it to 0, you get the critical points. So, that means that step 1 is find the critical points. How do you find out? After deriving, differentiating, equate it to 0, you get the critical point. There may be 1, 2, 3, any number of points. Second step, consider the end points. Consider the end points. What are the end points here? A and B in this example, A and B. Now, third step is find the value of the function. Find the value of the function at what points? At x is equal to A, the end point, x equal to B. Let us assume there are 2 critical points here, say x1 and x2. At x1 and x2. Or there may be only one point, there may be 2, there may be 3, there may be any number of critical points. Find the value of the function at all these 4 points. Then fourth step, the greatest among them. We will not be knowing which point it attains the maximum value. The greatest value out of these is called as the absolute maximum value. The least among them is called as the absolute minimum value. Here we need not go to the second derivative at all. So directly getting the first derivative, getting the critical points here, we can find the, we can find out which is the absolute maximum value and which is the absolute minimum value. Now let me try some problems in which we find the absolute minimum and absolute maximum value. So this is a common instruction, find the absolute maximum and absolute minimum value. The first problem is f of x is equal to 4x minus x square by 2, x belonging to the closed interval 2, 9 by 2. 2, 9 by 2. Now, as usual, find the derivative. It is 4 into 1, x square becomes 2x divided by 2. 2 gets cancelled. Therefore, f dash x is equal to 4 minus x. Now, what we have to do? To get the critical point, equate the first derivative to 0. That implies that 4 minus x is equal to 0 or x is equal to 4 is the critical point. So, in this one I am getting only one critical point. I am getting only one critical point. So, I have the end points, I have got the critical point. Therefore, next step is find the value of, find fx at what points? First one, fx, you write the values here. X is equal to minus 2, x is equal to 9 by 2 and x is equal to 4. So, two endpoints are minus 2 and 9 by 2. The critical point is 4. Okay. At first point, at x is first value, at x is equal to minus 2. The first end point I am considering. You go to the original function. F of minus 2 is 4 into minus 2 minus minus 2 the whole square by 2. That is minus 8. 2 square is 4 divided by 2. You can cancel minus 8 minus 2, that is minus 10. So, this is the value of the function at one point, one end point. Second point, f of, you can take the other end point, 9 by 2. But be careful, we have got a fractional value here. It is 4 into 9 by 2 minus 9 by 2 the whole square divided by 2. So, 2 ones are 2 twos are 2 into 9, 18. Here be careful, it is 81 by 4 divided by 2. 4 and 2 they go together to the denominator position, it becomes 81 by 8. Now take the LCM, LCM is 8 and 18 8s are 144 minus 81, that would be equal to 63 by 8. So, this is a second value. First value is minus 10, second value is 63 by 8. Let me go to the value of the function at the critical point. Here 4 into 4 minus 4 square divided by 2. 4 4s are 16, 4 square is 16 divided by 2 is 8. So, it is equal to 8. So, we got here 3 values. Let me write all the 3 values. Then we will know which is the biggest and which is the smallest. What is the first value here? First value, f of minus 2 equal to minus 10. F of 9 by 2 equal to 63 by 8. F of 4 is equal to 8. Now, which is the smallest? We can directly see that this being a negative number, this is the smallest value. Therefore, what you call this one? It is the absolute minimum value. Out of these two, which is bigger here? You observe this is 8 whole number. If you divide now, if this number were to be 64, it would become 8 8s. Now it is slightly less than 8. So this becomes the absolute maximum value. So, that is the absolute minimum value and this is absolute maximum value. So, this is how we have to find the values. So, the functions may be different, but the procedure is same. Now, let me move on to the next problem. F of x equal to 2x cube minus 15x square plus 36x plus 1 in the interval 1 comma 5. In the interval 1 comma 5. Here, as usual, let me get the first derivative. This is x cube becomes 3x square. So, 6x square. X square becomes 2x, that is 30x, and this is 36 into 1. Now, let me equate it to the first derivative to 0, that is 6x square minus 30x plus 36 equal to 0. Now, take the common factor 6 here, x square minus 5x plus 6 equal to 0. Now, 6 cannot be equal to 0, that means x square minus 5x plus 6 equal to 0. Now, you can see that it is a quadratic equation. You can factorize. The factors are x minus 2 into x minus 3 equal to 0. You know how to solve this one? The sum should be middle number, the product should be this number, minus 2 into minus 3 plus 6, minus 2 plus minus 3 is minus 5. Therefore, we get in this problem two critical points, that is x is equal to 2 and x is equal to 3 are the critical points, Now, how many, there are two critical points. And how many endpoints are there? There are two endpoints, 1 and 5. Therefore, find the values of the function, at all the 4 points. Write that one. Find fx at x is equal to 2, x is equal to 3, x is equal to 1 and x is equal to 5. So, one by one we will find out. First, the order is not important. Any point you can take first, the other would be afterwards. X is equal to 2. See, go to the original function, be careful. F of 2 would be 2 into 2 cube. 2 cube is 8, 8 2s are 16. 2 square is 4, 15 into 4, 60. 36 into 2, 72 plus 1. So, you add them, 72 minus 60 is 12. 12 plus 16, 28 plus 1, that is equal to 29. So, we get the first value to be 29. Then, let me take the second value, x is equal to 3. Now, calculate f of 3. The same thing, 2 into 3 cube is 27 into 2, 54. Here, 3 square is 9, 15 9s are 135. 36 into 3, it is 108 plus 1. So, you have to add the numbers here, 108 plus 54, 162, 62 plus 1, 63. So, 163 minus 135, then it would be 8 and 28. So, we get 29, we get 28. At what points? At the critical points. X equal to 2, 29. X is equal to 3, it is 28 we have got. Now, next is, let me take the end point. I told you already, this is not a rule. Any point you can calculate first. X is equal to 1. I am taking the end point. Put x equal to 1 here. 2 into, that is f of 1 is 2 into 1, that is 2. 15 into 1, that is 15. 36 into 1, that is 36 plus 1. So, I simplify this one. 36 plus 1, 37. 37 plus 9 is, plus 2 is 39. 39 minus 15 is 24. So we got 29, 28, 24. Lastly, be careful, the number is big here. It is 5, x equal to 5. We have f of 5. F of 5 would be equal to 5 cube is 125 into 2, that would be 250. 5 square is 25. 25 into 15 is 375. And 36 into 5. 36 into 5 is 180 plus 1. So when you simplify all of them, when you simplify all these values, now you will be getting the number 56. Okay. You can find out here, you can add the positive numbers. 250 plus 180, that would be 430. 430 plus 1, 431. 431 minus 375, 11 minus 5, 6, 12 minus 7, 5. That's what I have written here. It would be equal to 56. Now, let us see which is the smallest value and which is the biggest value. You observe 29, 28, 24, 56. Which is the smallest value here? 24 is the smallest value and 56 is the greatest value. So, what you call 24 here? It is called as the absolute minimum value. At what point it has occurred? At the point 1, that is at the end point, the first end point. The other one is 56, the maximum value. Therefore, this is the absolute minimum value and this is the absolute maximum value. So, in between points it has not got maximum value. See, in the previous one it was so, at a critical point no, it had attained the maximum value, whereas in this problem at the end points the function has attained one absolute maximum value, the other one absolute minimum value. Now, let me consider another problem. Here I am considering a trigonometric function. F of x is equal to sin x plus cos x. Sin x plus cos x, x belonging to the interval 0 pi. That is in the first as well as in the second quadrant. Whatever may be the function, the procedure is same. So, differentiate first one time, this becomes cos x, this is minus sin x. So, to know the critical value, critical point, now let f dash x be equal to 0, that implies cos x minus sin x is equal to 0. Now, let me rearrange the function. Cos x equal to sin x, or take cos x as the denominator of the other side, sin x by cos x equal to 1, that implies tan x equal to 1. Isn't it? It's not 0. We are taking cos x, so 1 is there. In other words, we are dividing both sides by cos x. Tan x equal to 1 means, what is the value of x here? Look at the interval. It is between 0 and pi. We have got a positive sign. You know that in the first quadrant only tan is positive because we have only first and second. Second quadrant it is negative. Therefore, x is equal to pi by 4 is the critical point. So, how many points we got? Only 1 point. Now, let me find the values of the function at 3 points, at x equal to 0, x equal to pi and x is equal to pi by 4. First one, f of 0, that is the first end point, that is sin 0 plus cos 0. You know that sin 0 is 0, cos 0 is 1, so it is 1. Next, second one is, you take the other end point, f of pi. So, sin pi plus cos pi. Sin pi is again 0, cos pi is minus 1, therefore, the value that we obtained is minus 1. Now, let me come to the critical point, f of pi by 4. F of pi by 4 means it is sin of pi by 4 plus cos of pi by 4. So, we have to do the actual calculation, 1 by root of 2 plus 1 by root of 2. Taking the LCM, which is root of 2, it is 1 plus 1. that is 2 divided by root of 2. On cancellation, we get it as root of 2. So, 3 values we got here, plus 1, minus 1 and root of 2. Now, we have to decide which is the smallest value and which is the biggest value. So, out of the 3 values, which you can consider as the smallest value? See, you know that the negative number is there, minus 1. Therefore, the absolute minimum value is minus 1. At what point it has occurred? It has occurred at the end point, the second end point, pi there. So, it is the absolute minimum value. The absolute minimum value, you write here, the absolute minimum value is equal to minus 1. Absolute minimum value is minus 1. Now come to the other 2 values. One is plus 1, the other is root of 2. Which is bigger? You know that root 2 is 1 point something. Therefore, this absolute maximum value is equal to root of 2. At what point you need not specify. If you want, you can write at x equal to pi, at x is equal to pi by 4. So, this is the critical point. So, critical point in this problem also, it has got the maximum value, whereas in the one of the end points, no, it has got the least value. Now, consider the next problem. F of x equal to 12x to the power 4 by 3 minus 6 into x to the power 1 by 3. See here, the function is, it's an algebraic function only, but the indices are not integers, isn't it? So, be careful when you do the differentiation. Method is same irrespective of the function that we are considering. So, 12 into, apply the formula x to the power n into x to the power n minus 1. 4 by 3 into x to the power 4 by 3 minus 1 minus 6 into 1 by 3 into x to the power 1 by 3 minus 1. So, you can cancel this 4 times. So, 16 into 4 by 3 minus 1 would be 1 by 3. You can cancel here 2 times, minus 2 into x to the power minus 2 by 3. Okay, you can, if you want to avoid the negative sign, you can take it to the denominator, x to the power 1 by 3 minus 2 divided by x to the power 2 by 3. So, like this you can keep. Now, our problem is to find the critical point. For the critical point, now here itself you can take the LCM and simplify, that is better. LCM becomes x to the power 2 by 3. So, this is by 1. So, 16 into x power 1 by 3 into x to the power 2 by 3. X to the power 1 by 3 into x to the power 2 by 3 minus 2. Look at this one. See, using the law of the indices, 16 into x to the power 1 by 3 plus 2 by 3. A to the power m into a to the power n is a to the power m plus n. Minus 2 divided by x to the power 2 by 3. That is, we are having f dash x equal to 16 into, look here, 1 by 3 plus 2 by 3, that is equal to 1. Therefore, you can write it as 16x minus 2 divided by x to the power 2 by 3. Now, this is at present f dash x. Now, to know the critical point, let me equate the first derivative to 0. That is 16x minus 2 divided by x to the power 2 by 3 is equal to 0. So, on cross multiplication, 16x minus 2 equal to 0, or x would be equal to 2 by 16, or it is 1 by 8. So, we got a critical point, a fractional one. So, x is equal to 1 by 8 is the only one critical point. So, we are having here, we are having the function which is little bit complicated. We have differentiated, equated to 0, we got the critical point. Now, let us find the values of the function at all the 3 points carefully. You have to be little bit careful at this for this particular problem. First one, f of 1, f of minus 1. the first end point here, f of minus 1. Wherever x is there, write the value minus 1. It is 12 into minus 1 to the power 4 by 3 minus 6 into minus 1 to the power 1 by 3. See, we should know about the cube root here. Now, let me rewrite this one using the law of the indices. Minus 1 to the power 4 whole to the power 1 by 3, and here 6 into minus 1 to the power 1 by 3. See, minus 1 raised to the power 4. Minus 1 into minus 1 into minus 1 into minus 1. It's an even power, so it becomes plus 1, isn't it? So 12 into 1 to the power 1 by 3 minus 6 into minus 1 to the power 1 by 3. In other words, we are calculating the cube root of 1 as well as minus 1. Actually, one root would be real, the remaining two would be imaginary roots. So this is 12 into 1, that is minus 6 into minus 1. So minus of minus plus, that is 12 plus 6, that would be equal to 18. So we got the value of the function at x is equal to minus 1, that is the first end point I am calculating, that is equal to 18. Next, what is the next point I am having? I have to calculate at the next end point. I am calculating at the end point, then I will come to the critical point. So at x is equal to plus 1, you go to the same function. It is 12 into 1 to the power 4 by 3 minus 6 into 1 to the power 1 by 3. See, when it is 1, a positive number, it raised to the any finite power, it would be equal to 1. Therefore, it is 12 minus 6, that would be 12 minus 6, that would be equal to 6. See, in the previous one, though here also we are calculating the cube root only, but it is 1 here, so directly I could write the value. Cube root of 1 is 1 in both the cases. Okay, so it is 12 minus 6, the value would be equal to 6. Now, we have to go to the critical point. What is the critical point here? X is equal to 1 by 8. Here the calculation is a little bit difficult. Follow it carefully. So it is 12 into 1 by 8 whole to the power 4 by 3 minus 6 into 1 by 8 to the power 1 by 3. So again I am using the law of the indices. See, write it as 12 into, you know that 1 by 8 is actually 1 by 2 the whole cube, isn't it? 2 cube is 8. Now to the power 4 by 3. I am writing it as it is. Similarly, it is 1 by 2 the whole cube to the power 1 by 3. Now using the law of the indices, this 3 can be cancelled. So what is remaining? 12 into 1 by 2 to the power 4. 1 by 2 to the power 4, and this is 6 into, it is 1 by 2. Okay, directly you can cancel 2 3s, and here you have to expand this one. 12 into 1 by 2 to the power 4 is 1 by 16 minus 3. So you can cancel 4 3s are 4 4s. Therefore, f of 1 by 8 equal to, now the number is 3 by 4 minus 3. 3 by 4 minus 3. So you have to take the LCM here. LCM being 4, it is 3, 1 here, 1 4s are 4 3s are 12. So we have the value minus 9 by 4. So we got 3 values here. One is at minus 1, it is plus 18. At plus 1, it is plus 6. At 1 by 8, it is minus 9 by 4. Now, which is the least among these one? The least value is minus 9 by 4. How do you write that one? The absolute minimum value is minus 9 by 4. At what point it has occurred? At the critical point. Next is the absolute maximum value is 18. At what point? At one of the end points it has occurred. So, you have to solve these problems on absolute maximum minimum value in this way. First you find the first two derivative, equate it to 0, you get the critical point or points. Then find the value of the function at the two end points and also at the critical points. The greatest among them is the absolute maximum value. The least among them is the absolute minimum value. So, if you write, usually it is given for a 2-mark question. Say, but whatever it is, now this much of calculation would be certainly have to be done here. Okay. So, in the next, this completes the third application, maxima and minima. In the next session, I will be teaching you about the fourth application, which is known as the rate measure. So, I will meet in the next session. Thank you.